Okay, how's everybody today? Good, I'm doing well. Okay, looking forward to Friday. Okay, definitely, definitely. But a few big items. Don't forget, in a couple of days on Monday, we're having our first exam of the 6 weeks right before spring break. It will cover the relations and functions lesson we went over, linear functions, quadratics, exponentials, basically all that review material. So there's not going to be any trig on there. But more than likely next week we'll have maybe an exit ticket with the trig material, probably a quiz right before the break. But the other item that's probably way more important, we have exactly 1 week until what? The IAs are going to be due exactly. So I'm hoping at this point we are putting the finishing touches on all those projects. Heard a yes. Okay, so that makes me feel happy. All right. If you do have any questions, you need me to look it over one more time, just let me know. If you do want to turn it in early, you're more than welcome to, but we do need to get that turned in next week. I'm going to be taking Friday the 8th to go ahead and grade those. All right, we're going to record them as an exam grade, but also for your IB grade, it counts 20%, with the other 80% coming from your paper exams. And speaking of, I was looking at the calendar. I want to say that when we get back from spring break, we'll have 7 weeks to go ahead and get ready before the exam is here. So we really don't have that much more material to talk about. Once we get through the trig, a little bit of geometry review, we're going to have our last unit on calculus, and then I'm hoping we should have at least a good 3 solid weeks to review before the paper exams roll around. Okay, so a lot's going to be happening. Any questions? Okay, well, let's take a look at our third focus activity. Now, the focus activities are going to be due on Tuesday. Thinking tomorrow that we'll get our fourth and final one. I do have it ready. It's copied. So if you want to turn that in early tomorrow, that's perfectly fine. If not, Tuesday is when I'm going to be looking for them. But let's see. It says a rhombus has diagonals of length 10 and 6 centimeters. Find the smaller angle of the rhombus. Okay, so the smaller angle, I'm guessing it's going to be one of those angles right there. Okay, yes, ma'am. They are not multiple choice. They are open-ended, yes. Mhm. But it covers all the material that we've talked about throughout the entire school year. So you'll have 90 minutes for each of them. Paper one is going to be 15 questions. Paper two is only 6 questions. But that's where each question usually has an A, B, C, D, E, F, G, and they're all very progressive. So in order to get a later answer, you have to have gotten a previous answer. They really like those problems to build on themselves. You really don't see a whole lot of that in paper one. No, there's no essay format. Um, I'm actually going to go ahead and give you last year's test and administer it to you. I'm going to give you the time to look it over along with the reviews that I have set up. And you'll notice there's going to be boxes, like there'll be little lines over to the side of the problem where you'll put your final answer. Now, sometimes you might have to write a small sentence or something like that. Like think of chi-squared. Do you remember that statistical strategy? They might go ahead and have you write like the null or the alternate hypothesis, things like that. But no, there's really no short essays on there. And I think I've talked to you guys about this before. Each part of the problem will have brackets with, say, a little number over to the side. Have I talked to you about that yet? Okay. Basically, that's how many marks you can get for that particular answer. Now, a really good rule of thumb is subtract 1 from this. That's the number of steps of work you need to be showing. Okay. So if you ever come across one that's only worth 1 point, that means pretty much you shouldn't have to do anything to find the answer. It should be right there, maybe in a graph or someplace that's very obvious. Now, if you were to get something like maybe 3 or 4 marks, that's definitely something that I would consider showing some work for. Okay, and I'm going to talk more about that, when we get there. But yeah, I want to make sure you're accustomed to that when we get there. So I haven't done that already. I could have sworn I did that at the beginning of the year. Huh, okay. Okay, that's okay. That's okay. Obviously, I don't remember either. So there you go. All right. So good, good, good. So Evelyn, did you have any more questions or anybody else? You guys are going to be ready. I mean, we're going to have time for review, and I'm confident. You guys are way better than the class I had last year.
Thank you.
You're very welcome. Okay, even though I'm recording that, I will say it. Yes. Yes.
Just like getting, I don't know what like it is, but like there's like a ID Math Studies like review book that you can like order. I don't know if
Oh, do I suggest getting a
Yeah,
math studies
please,
review
yeah.
book? I've actually never looked at one of those. If you wanted to get one, I'd be willing to look it over. But as long as it covers the same material we've been going over in class, you should be good to go. Yeah. Okay, so good. They sell that at what, Barnes and Noble or Amazon or something like that? Okay. All right, good. Any other questions? Okay. Then let's get back to our rhombus here. So what I did, because we have to somehow think of this in terms of right triangles, because that's what our trig introduction has been over. Let's think about a rhombus. And this goes all the way back to geometry. What are some characteristics of a rhombus? Like if I were to draw the diagonals of a rhombus, we know a couple of things about them. Do you guys remember what they are?
All of the triangles.
They bisect each other. And what's that, Eli?
All four of the triangles are like equivalent.
They are going to be equivalent. Now, not only do the diagonals bisect one another, but they cross at what angle? 90 degrees. They are perpendicular to each other. Okay. So I know that this is the same length as that, and I know this is the same length as that. So we can go ahead and just say, okay, let's say this diagonal here is the 10 centimeters. So this would be 5, this would be 5. The other one would be 6, so this would be 3, and this would be 3. So when it talks about finding the smaller angle of the rhombus, okay, I would probably go ahead and look to find that angle of the triangle, one of the four that Eli was saying is congruent. But then we'd have to do something at the end. We'd have to multiply by 2. There we go, because that would only be half of the actual angle we're looking for. So is everybody okay with what I'm doing? Okay. All right, well, let's see. If this is the angle that I want, what is 3 with respect to that? Is that the adjacent, the opposite, or the hypotenuse? That's the opposite. 5 would be the adjacent. And this would be the hypotenuse, and it's always easy to tell that because it's always directly across from the 90-degree angle. So what trig function can I use that has the opposite and adjacent? It is tangent. Here we go. So I would go ahead and say tangent of theta is equal to opposite over adjacent, so 3/5. Now, we started looking at these yesterday. How can I find the angle given the ratio? Yeah, use the inverse. There we go. So I evaluate a trig function at an angle to get a ratio of the sides of a triangle. So I'm going to take the inverse to get the theta measure. Okay. And again, like always, we just want to make sure that our calculators are in degrees, which I believe they should still be. So let me get out of here. Document B. So tangent inverse of 3/5. Okay. So the angle should be, let's say, about 31 degrees because we got a 0.96. But we did say what? Oh, that is the smallest angle, but we have to multiply by 2 because remember, that's half of the angle we're looking for. Okay, so if I'll go ahead and double it. So 61.9, okay, 3. All right. Would you want me to go ahead and put 61.9 or let's say 62? 62? Okay. All right. Okay, so while theta was about 31 degrees, the angle we're actually looking for is about 62 degrees. Okay, questions? Anybody have that completed before we start? No? Okay. We'll go ahead and put that to the side. You have 3 now, and I believe there are still some extra copies of 1 and 2 over here if you've misplaced them. But you'll get the 4th one tomorrow, and they're due when? Tuesday. All right, so let me shut this down here. You want to save changes? Yes, why not? Okay, well, we finished up with the right triangle trig. Everybody seemed to be doing pretty well with that. So now we're going to go ahead and move on to another concept, the law of sines. So we won't be looking at right triangles. We're going to be looking at oblique triangles, triangles that do not have a 90-degree measure. So basically it's going to fall into one of two categories. Either you're going to have an acute triangle, all three angles will have to be less than 90, or you're going to have an obtuse. One's got to be larger than 90, but the other two will be acute. Okay, so let's see here. If a triangle is not a right triangle, you cannot use the Pythagorean theorem or the right triangle trig relationships to solve it. Therefore, we need other ways to solve non-right triangles, and one way is the law of sines. Okay, so the law of sines is used when you know three pieces of information. Okay, the measure of one blank and any two angles, with one of the angles being across from the given side. Well, what do you think that blank is? It is side. There you go. Okay. Now, the law of sines. In fact, does anybody remember the law of sines? Okay. Now, remember, in our formulas, we always go ahead and say that the capital letter represents the angle measure, while the lowercase represents the side length. So, we're going to say sine of angle A over side A equals sine of angle B over side B, which is equal to sine of angle C over side C. Now, you're only ever going to use two of these at once. Basically, you're going to create a, what do we call it when one fraction equals another? Starts with a P. Proportion, that's exactly right. And to solve a proportion, we cross multiply and then divide. Okay, now you can also do this because fractions are actually really useful and you can manipulate them in a lot of ways. I could just flip all of these. I could go ahead and say side A over sine of angle A equals side B over sine of angle B equals side C over sine of angle C. Okay, you could flip them all the same way. Typically, I always go ahead and use the top version. I always like to put the angle up top, but if you want to try something different, it is not going to change anything. Okay, so like I said, you're only going to use two of the ratios at any given time. So here's our first example. Let's just get right into it. Solve the triangle. Now this is an angle side case. So I have two angles and then the side not between them. And do you guys remember from geometry all those theorems and postulates going through side, 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 and angle, side, angle? Good times, right? Okay, Carolina's like, yes, it was an amazing time of my life. Okay. She described all of that verbally just by shaking her head. Okay. Now, here's how I like to go ahead and describe it. When you're dealing with an oblique triangle, and that is a triangle that does not have a right angle, and you're trying to find all the missing information, like we need angle C, I need side B, and I need side C. Well, the only way you can use law of sines is if you have what I call a pair. You have to have a pair, an angle and the side directly opposite that. Now, if you're ever given a triangle where you don't have a pair, more than likely you're going to have to use the law of cosines. That's coming up later. Okay? So because I do have a pair, I can go ahead and continue. So now, what would be the easiest thing to find here? And I don't even need to use the law of sines.
Angle C.
Angle C. Because we know the interior sum has to be 180. We've already got 100, so C has to be 80. So this is 80 degrees. That's easy enough. Okay. So now using that pair that I was just talking about, I'm going to go ahead and begin the law of sines. I'm going to say the sine of 40 degrees over 12. So see, I'm using the angle measure and the side directly opposite that. Equals. And now because we have the other two angles, really how I continue, it just depends on what I would like to find first. Do we want to find side B or side C? C? Okay. So let's find side C first. So that means I've got to use the 80. So I'm going to say sine of 80 over C. All right. And now for a proportion, you cross multiply. So this would give me C times the sine of 40 degrees is equal to 12 times the sine of 80 degrees. And how am I going to solve for C? Yeah, just divide by the sine of 40. Anything divided by itself cancels, even a trig function. divide this by sine of 40 degrees. And now we just need to figure out what that is. Okay. So let's see, 12 sine of 80. I'm going to come on over here to my calculator. And I get rid of this, control divide, so 12 sine 100, no, it was 80, right? And then what was the bottom portion? I forget. Sine of 40, okay. Sine 40, okay. So as soon as I push enter, I should know the length. What is it, Samir? Okay, so that's perfect. 18.4 units, whatever unit of measurement we're dealing with. Okay. Yeah, there we go. Down. Okay, so I'm going to do this. There we go. Kept jumping up. So C is about 18.4. Okay. Now, if we were still dealing with right triangle trig, I mean, we could go ahead and just use the Pythagorean theorem, but unfortunately we have an oblique triangle. Now, here's the thing. I would recommend sticking with the same pair. I would go ahead and reuse sine of 40 over 12. We can use 80 over 18.4, but a lot of people tend not to use the approximated version in the calculator, and because we rounded it, could that affect the answer? Yeah, so I always recommend sticking with the one pair you started with. So I'm going to go ahead and say, once again, sine of 40 over the 12 equals. Now I'm going to go ahead and take sine of 60, because that's the angle opposite the side I want, over side B. Now again, you can follow the steps, cross multiply and divide, but could anybody give me the expression that I would need to plug into the calculator in order to get side B? What would the numerator have to be?
Sine of 60.
Okay, so it'd have to be 12 sine of 60. Then it would have to be divided by sine of 40. Okay. Anybody want me to actually show the multiplication that we're going to get that? Or is everybody okay? Okay, so let's see if it'll take it from here. Control divide. So 12 sine 60 over sine. Oh, interesting. There we go. 40. All right, what do I get when I push enter? Okay, so let's say 16.2. Okay, there we go. And there you go. That is the law of sines. Okay. Hey.
Is there like a rule on how many decimal places we're supposed to go to?
Typically, you remember IB likes 3 sig figs. Some of the questions will be specific, and they'll ask you to round to a certain number of decimal places or a certain number of sig figs, because that was part of what we talked about. But if they don't say anything, typically I think 3 sig figs is a great way to go. All right. Anybody have questions? Bless you. Okay. So how many people have seen this before and you're like, oh, I remember that? Okay. Kind of, sort of. Okay. Nice, nice, nice. Okay. Well, here we go. Solve triangle ABC. If side B is 12.6 centimeters, angle A is 42 degrees, and angle C is 75 degrees. So this is an angle side angle case. All right, so the only thing here is they haven't given you a picture, and I always recommend, especially with these trig problems, sketch a picture, because that always helps give an idea of what's going on. And it doesn't matter where you label A, B, and C. Okay, so let's say A, B, C. Typically, that's how I like to go ahead and label my triangle, as long as all the information is correct in it. So we know A is 42. Okay, we're also given C is 75, and we know side B, so it would have to be this one, is 12.6 centimeters. Okay. Now, we can only use the law of sines if we have a pair, and do I actually have one?
No.
Oh, now be careful. There you go. I can easily find this, which does give me a pair. So kind of technically they are giving me one. Okay, that means you need an angle measure and the side length directly across from it. That's the only way you can use law of sines. Okay. Now, if you have no pair, you've got to use the law of cosines. Okay. All right, so let's see. 75 plus 42. Okay. So 117. So what would the angle B look like? 63. And there we go. Okay, so now that we have a pair, I'm going to start off by saying sine of 63 degrees over 12.6 equals, again, the second ratio, you're right, depends on what you want to solve for. Do we want side C or side A?
A.
A. Okay, so I'm going to use sine of 42 over A. Okay, so let's do the same thing. Instead of showing the cross multiplication, what am I going to type in the calculator to get A? What would go up top? 12.6 sine 42 degrees over the sine of 63 degrees. Okay, so let's see what we got here. Let me get out of this document B, control divide. So I got 12 sine 63 over sine, what was it, 42? Okay, 42. And what should I be getting? Okay. I'm getting 15.97. Did I type it in wrong? Was it 63? Oh, did I switch them? I remember the numbers correctly, but I got the wrong. Okay. Just seeing if you were paying attention. And okay, obviously you were. So that's 42. And that's 63. There we go. So 9.01. Okay. So let's say 9 centimeters. Okay. So this was side A, so about 9 centimeters. Okay. All right. And then we've got one last one. So again, I'm going to stick with the same pair, sine of 63 over the 12.6. What would the second ratio equal? What over what? Okay, so sine of 75 over side C. So side C should equal 12.6 times the sine of 75, okay, divided by sine of 63. Okay. And let's see what that is going to give me. So come back over here. Let's document B out of it. Okay, control divide. So 12.6 sine. I want to make sure I get it right this time. What was the top one again? 75. Okay, so we had sine of 63 down below. It keeps doing that today. That's weird. Sine of 63. All right. And what should I get when I push enter? So 13.
On the other one, you only put 12 times sine of 42 over sine of 63.
Did I?
So it's like 6. But it was rounded, so the answer was like 9.5.
So it was 9.5? Okay, there you go. Okay, so let's go ahead and change that. Sorry. 9.5. And what was the other one? 13.7. Okay, so let's say that. Okay. I'm on the ball today. All right. Top of the world. Okay. Okay, questions. Anybody having a hard time with law of sines? Okay. So I'll tell you what, why don't I go ahead and turn it over to one of you folks, and hopefully there won't be a mistake, which is much less likely. Who wants to do the next one? Let's see, we've got side A is 15.2, angle A is 24 degrees, and angle B is 50 degrees. Angle, side case. So many hands going up. I just need one. Yes. I'll even go ahead and create the triangle and fill in all the information. So let's say this is A, B, C. So this is 15.2, this is 24 degrees, and this is 50 degrees. Okay. All right, who wants to come on up and show me? Okay. Michelle says she'll come on up. Perfect. Okay, so she gets right to it. Sine of 24 degrees over the 15.2. That is the pair. Good. Equals sine of 50 over side B. Perfect. Okay, so sine of 50 times 15.2 over sine of 24. And that expression will give me the length of side B. Okay.
Do I have to do it on?
Oh, you can just type it in real fast, or does somebody already have that? For side B.
28.6.
That's what I got. 28.6. Perfect. There you go. Thank you, Michelle. Okay. Now, all we need left is angle C and side C. Well, what is the length of, or should we measure of angle C? Well, it's got to be 106. Okay. Just subtract the other two from 180. So 106. Okay. Now I need someone to come on up and help me with side C. Who wants to have just as much fun as Michelle did?
I love it.
All right. Eli loves fun.
I just moved the entire picture down this way, so I'm sorry.
That's okay.
I did it, yeah. Okay, sweet. So if we do, so we can just, I'm just gonna use angle A sign again. That way we can just keep it consistent.
Okay.
So it'd be the sine of 24 over 15.2 equals the sine of 106 over C.
There we go.
And then, do you want me to cross multiply and show it, or do you just want to?
So would you guys like him to show you the steps, or is it okay to do what we've been, just write the expression out? Expression's fine? Okay.
So now I punch in the calculator now?
Oh, okay. Yeah, if you just want, if you do.
I thought that's what it was.
Oh, okay, go for it.
Control device.
Oh, okay. Let's see here.
Okay, so it's control divide, and then do the
Settings.
15.2
Oops, I want that.
2 times the sine
Degree. Make default.
times the sine of 106.
Should be okay. That's in
do,
degrees.
Thank
Mhm.
you.
And then you just divide it by the sine of 24. And then I got 0.9.
Okay. So 35.9, we could probably go ahead and say
36.
36. Perfect. That's exactly right.
Great.
Okay, so let's come back up here. 36. Okay. Thank you, Eli. Okay, we've got one left. Who wants to take care of this last one? Peyton, you want to do it? Okay. Okay, so we have angle A is 50 degrees, angle B is 30 degrees, and side C is 9, whatever measurement we have. Okay, so 50 30.
I just added them and subtracted from an 80 and I got
Okay, so this is an obtuse triangle. We know that's 9. There we go. So there's our pair. We have a measure of 100 across from a length of 9.
Do you want me to do all of it or just A?
Well, is the expression just okay? Okay. Or are you talking about the entire problem?
No, like, did you want me to do the expression?
Oh, sure, yes. Okay, so 9 times the sine of 50 over the sine of 100.
Do you want to do the calculator?
I'm sorry.
Should I just write the answer since I already did it?
Okay, she's got 7. What do you guys think? I'd say that's perfect. Exactly right. Okay. Has anybody actually already figured out what side B is? Okay, Gabby, what'd you get? 4.6. That's exactly what I got. Okay. Sierra, you got that too? All right. 4.6. There you go. That is the law of sines. Okay. Now, in fact, I'm going to go ahead and stop there because the next part of this is what we call the ambiguous case. That's where it can get a little more difficult, so I'll wait until we have more people here to do that. The only other thing I could do, because we still have actually a decent amount of time, would anybody like to see a quick little proof as to the law of sines? I mean, it's not going to be on the paper exams. It's nothing I'll hold you responsible for, but would anybody like to know why we use the rule we do? Like how we got that rule to begin with. Like actually derive it. Yes, sir. Yeah, passes right over here. So I'm going to use a triangle that we've actually been using all day. Now, this won't be a complete proof, and you'll see why in just a second. So let's say we have A, B, and C. Okay, so let's say I go ahead and drop an altitude and call it the height, right? Okay, so I'm actually creating 2 right triangles. Okay. Well, let me go ahead and this is side A, this is side B. Oh, yeah. This is side C, and this is side B. Okay. Well, why don't I go ahead and come up with some trig equations based on the height, the altitude that I just dropped, right? So let's say I were to take the sine of angle A. Now remember, what is sine's ratio? Okay, opposite over the hypotenuse. So because I've dropped this altitude, this is a right triangle, so the opposite is H, the hypotenuse is going to be B, right? So I could go ahead and say that the sine of angle A is equal to the height over side B. Now, let's go ahead and do that over here as well. Okay, let's say I go ahead and take the sine of angle B. What would that ratio be? H over A. So I can say sine of side B is equal to H over A. Now, let's go ahead and solve each one of these for H. Okay. If I were to multiply this one by B, if I multiply this one by A, left myself just enough room. Okay. I see that the height is equal to B times the sine of angle A. Here I have that the height is equal to A times the sine of angle B. Anybody think they know where I'm going to go from here? Samir says set them equal to each other. They both equal the height, so therefore they equal each other. I can say that B times the sine of A is equal to A times the sine of B. So if I go ahead and divide through by B, but if I go ahead and divide through by A at the exact same time, the A's cancel, the B's cancel. There's one of the proportions that we've been using. Now remember, I said this is only going to be a partial proof, right? You see, I've got to do the same thing 2 more times going around using different pairs of angles. Okay? But that is where the law of sines comes from. Make sense? Okay. Now, the proof for the law of cosines is actually much, much larger. That one I'm probably not going to show you unless anybody just really wants to see it. But just for fun, because we're in math class and math's always fun, right? Does anybody actually remember the law of cosines? It's a much longer formula. If you don't, that's okay. I'm not going to go ahead and give it to you here. We're going to talk about it next week. But nobody, does that sound familiar? No? Okay. So we'll go ahead and stop there.